Topics covered in circles. Welcome, everyone. Today, we begin our exploration of circles, a fundamental pillar of Euclidean geometry. This topic serves as a vital bridge, moving us from simple shape recognition toward more complex spatial analysis. Our primary focus will be on the intrinsic properties of circles, specifically the concept of tangents, which are lines that intersect a circle at exactly one point. Throughout this unit, we will examine the theoretical foundations of tangents and the geometric theorems that govern their behavior. We will also conduct a detailed analysis of how many tangents can be drawn from points located on, inside, or outside the circumference of a circle. After we establish these mathematical foundations, we will move on to discuss how these principles are applied in various real-world engineering and technological contexts. Real-world applications of circles. Circular geometry is essential in engineering and mechanics, particularly in the design of gears, pulleys, and wheels, where precise circular principles ensure smooth motion and mechanical efficiency. In architecture and civil engineering, the properties of circles and arcs are critical for maintaining the structural stability of complex structures like domes and arches. Beyond Earth, the study of circles is indispensable in astronomy for accurately mapping planetary orbits. Even the modern technology we rely on every day, such as GPS and radar systems, functions through a process called triliteration, which is fundamentally rooted in the geometry of intersecting circles. Now that we have explored the theoretical foundations and the geometric properties of tangents, you might wonder how these abstract concepts apply to the world around us.